Hello, my name is Sawyer Mastro.
I'm Javien.
I would like to start this off by saying thank you to PSA and Wilkes for letting us be a part of this internship and just teaching us as much as you have. So the internship's name is Career Exploration and Robotics, or Explore NEPA. So I want to start off by talking about PSA. They are a manufacturing warehouse out in PSA. They have a secondary location out by Pittsburgh. They focus on engineering and machining. They have multiple PLCs and CNC machines. So the CNC machines are just automated machines. So you put a file in and it generates a code to run on an XYZ axis to create a part for you. And PLCs are the computers that the robotic arms or all the robots that you see in a warehouse use. It's a programmable learning computer, logic computer. So for the first 2 weeks at PSA, on the first day we came in and we got a tour of their warehouses, and we were allowed to talk with people at PSA about what they do there and talk to each other about the other school and who they are. After a few days there, we got used to who we were a part of and the groups that we were forced into in groups of 5 separated from each other. My group was me, Adiel, and Austin, along with Caleb and Iman. We were put with Corey and Ed first, which focus on machining and mechanical engineering along with inspecting the parts that are made. So we got to work with calipers and just any tool to measure objects, really. We also got to, on the last day of these 2 weeks, see the inspection shop, where we got to see what a CMM machine is, which is the machine on the bottom corner there. It inspects parts and will drop points to see how correct a part actually is, and if it's up to spec to be put onto a production line or out to where it needs to go.
Okay, for the first 2 weeks at Wilkes, we worked with Dr. Zoo and NOS robots, for example, it's right there. And then at PSA, Chris, which he's not here, we worked on breadboards. Later on in the video, since I don't have a video on the slideshow, since I don't have a video, you guys will see like kind of an example on what we did at PSA.
For the second weeks at PSA, we worked with Dan in the back in the pink shirt. He is the head of the drone committee at PSA. We got to use Q ground control, which allows you to set up your own missions and allows you to see a model of the drones flying. We also got to work with an actual drone made out of parts around his office. We were allowed to take it apart down to taking the housing off the electronics, and he told us about everything that we asked a question about. We got to learn how things like GPS scanners work and how they send signals to each other. And we also got to create our own robot from this website right here, eCalc. And there's just a bunch of places that you select, and you can select motors to the type of body that you want in your drone. At Wilkes that week, we used breadboards, and we really focused on just understanding circuitry. You can see on the corner of the breadboard with the photosensor. The photosensor will take in light and it will control the amount of voltage that's sent to the LED.
The second 2 weeks at Wilkes, we took MATLAB courses, which is basically a site where you can take like simulations. So, for example, we took 2. It was on how different machines work together, like parts, for example, and then we took 1 for coding. And the week at Wilkes, we then learned about breadboards and learned about the circuitry.
For the third set of the 2 weeks at PSA, we finally switched to the other group's mentors. Me and my group worked with Livy at this time, and we worked on how machine lines work and the machines that go into them. We also learned about ladder logic and PLCs, and MATLAB on-ramp and MATLAB Simulink, where we got to learn about coding and how math works, basically. At Wilkes that week, we were gifted a kit by Dr. Zhu in the engineering department, which we got to put together, learn how to put it together with an instruction sheet inside of it, and got to learn MicroPython, where we got to code the sensor on the front of the camera to go around the maze.
After 2 weeks at PSA, so Libby taught us on how to do ladder logic and the type of different machine layouts. So when Libby taught us that, our group, we then worked on a fictional closet on where, like, it picks your outfit depending on the weather, like, they were talking about.
For the final 2 weeks, my group worked with Chris. He's not here right now, but he specializes in electrical engineering, and electrical engineering is the groundwork for PLCs. As you can see, it's very similar to the ladder logic on the last slide. So he taught us about the electronics behind it, and also taught us how the CAD models of the arms inside of actual warehouses work, and how if you adjust one thing, you would have to relate a lot of other information to it and just change your entire design sometimes.
Okay, so I basically know how to build a drone now. Dan taught us, we assembled and disassembled it. And then Ed taught us, so this is actually like, it looks like a test tube, but it's not. It's the original form of a water bottle. And Corey taught us on how different parts have different kind of dimensions and stuff like that.
So since we covered everything that we did at the places, I wanted to take a deep dive on some of the things that we did. So the robot that we have is broken up into 3 easy parts: sensors, hardware, and electronics. So the sensors you can see in the top over there, the grayscale sensor is the 3 dots, and they take in light and read between 2 different light frequencies, and will say where something is depending on a 1 or a 0. The sonar sensor will emit a sound, and when the sound bounces back off of it, it will read it and say a distance where it is, and you could use that to track it by keeping it turning. The hardware of the robot is mostly made out of plastic. We have 4 motors on it, as you can see in this photo here, which are then attached to the wheels. We have a servo where the sonar sensor has housing that's mounted on it, and we have a picture of all of the hardware in the top left corner. For the electronics of the robot, it mainly uses a Pico, a Raspberry Pi Pico, and a Raspberry Pi Pico RDP, which is a robotics development platform. The Pico allows you to store code on it, and then the RDP allows you to talk with that code to the electronics and actually make the robot move. The other electronics on it are the sensors, the RGB lights on the bottom and the back of the robot, and the battery pack on the robot too. Some of the drones that we got to see were the ones that we took apart and put back together, and one of the drones that was sent out a few weeks ago too. We got to see a live flight of it. We also got to hear some of the stories about other drones that were made there, one of them being what Dan is currently working on. He's working on a drone to basically fly in clouds and collect data for a company a few states over. How this program affected me was, before I came in, I was really questioning what I wanted to do in the future. I was on the wall between robotics or doing a trade, and I still am a little curious about trades, but it definitely steered me away from robotics and more towards mechanical engineering. The program really opened my eyes to what engineering is really about, and it's not just math and science, which I thought it was. It's a lot more problem solving, going out to places and just hearing people about what they need or what problems they have. It's definitely a lot more critical thinking than I thought it was, but it's pretty fun.
Dr. Zhu and the team members, you guys really changed my mind, and I think I'm going to the Air Force for engineering. I was just going to go for a pilot, but I got to go to college for that anyway, so I might as well be an engineer at the Air Force, and I really appreciate it. Thank you.
Any questions?
All right, thank you guys so much.